All right, in this one we're going to look at number 2 from our inverse derivative College Board questions. So in this case, they say let f be an increasing function, f of 0 equals 2, and the derivative is given by this expression here. Find f double prime. Again, people have been confused. How am I supposed to do this if I don't know what f is? You know what f prime is. You can go from f prime to f double prime. You don't need to know what f is to do that. If we just stop and slow down, what are they asking for? What did they give me? How can I bridge that gap? Well, just take the derivative. To take this derivative, we're going to definitely use some sum and difference rule. Keep these things separate when I'm thinking about them. And this one needs a little bit of chain rule here. So f double prime of x is going to be pi cosine of pi x. If you need to stop and show the work for that, please do. Plus its chain rule. 2x. Now plug in -2. That's your job. Your job. Make sure, of course, that your job is also to understand how I did that. Chain rule, power rule. Part B, and I'm going to leave that up to you. Write an equation for the line tangent to the graph of this at x equals 0. Okay, so again, I stop and I think, all right, what are they asking me for? They're asking me for a tangent line. Anytime they're asking me for a tangent line, I'm thinking, all right, point slope y minus y1 is equal to m times x minus x1. Now, typically, they've given me the x value for x1. Oh, hey, they did. That's 0. Sometimes they gave me y1 too. Oh, hey, they did. Well, not quite, sorry. A little bit more to that than I thought for just a second there. So we'll come back to that. They didn't directly give me this in the most friendly way. Not too bad, but not as friendly as sometimes it is. So they gave me the x1, it's 0. I'll have to figure out this y1. And then I need to figure out the slope. And we figure out the slope, of course, by finding the derivative at the x value, because that's the definition of the derivative. It's the slope of the tangent line. So I need to find the derivative of this thing. And so again, many of us are concerned, well, how am I supposed to find the derivative of this? I don't know what f of x is. Well, let's see. Part B. Actually, no, part B. Go away. So as I look at that, I can think of that one of two ways. I can think about it as a quotient, 1 divided by f of x, or if I wanted to, I could think about it as f of x to the negative first. Now I certainly cannot think about it as f inverse of x. The reciprocal of a function and the inverse of a function are different things. Sine inverse is not the same as cosecant. Cosecant is the reciprocal of sine. All right. I'm going to think about it as a quotient because I prefer quotient rule to chain rule most of the time. So quotient rule says that dy dx here, the derivative, y prime will say, is equal to low. Hey, that's just f of x. D high. Well, the derivative of 1 is 0. Minus high, that's just 1. D low. Well, I don't have a function for f, so how am I supposed to know its derivative? Well, let's just call it f prime of x. Because guess what? They gave me that. And then f of x squared. Low, d high, minus high, d low, square the bottom, and away we go. Now, we're looking at it maybe for a second, we're like, oh, wait a second though, Mr. Shields. They gave me f prime, but I still need to know f of x for both of these parts. Well, let's look at it individually. Here, I do not need to know f of x because multiplied by 0. Here, though, I still need to know f of x. But remember, just like in the previous problem, the question isn't what is the formula for this derivative. The question is what is the value of this derivative at x equals 0. And can I plug 0 in here and get a value based on what they told me? Yes, because they told me that f of 0 is 2. So y prime, given that x equals 0, is going to be negative f prime of 0 over 4, because again f of 0 is 2, and I'll square that. Now f prime, I have to figure out, based on what they gave me, what f prime of 0 is, but again I can do that. And this isn't too bad. Sine of 0 is 0, plus 0, plus 3, that's 3. That's negative 3/4. And that's m. That's the slope of my tangent line. Now I also have to know my y1, which is, what do I get out of this function when I plug in 0 for x? Well, plug in 0 for x, and it becomes f of 0, which is 2, and 1 over that is 1/2. So m we have, x1 we're given is 0, and y1 is 1/2. And then I can put that together as my tangent line there. Okay, part C, get rid of this, rewind, pause and write it down if you need to. Part C. So g is this function, and we need g prime of 2. So I've got to, again, slow down. All right, I need g prime of 2. Well, that means this is g. I need to take its derivative. How am I going to take that derivative? Well, g is f of this thing. So that means I have a function shoved inside of f. Hey, that's chain rule. So I need chain rule here, but I actually need 3 parts of chain rule. Innermost part, u is equal to 3x squared plus 4. Next, v is equal to the square root of u, which we like to write as u to the 1/2, because then I can remember to use my power rule. And then g is equal to f of v. Take the derivative of each of those pieces. First part, nice and straightforward, power rule. U prime is equal to 6x. V prime, again power rule, 1/2 u to the negative 1/2. I should have said this earlier, but a couple people when talking about this were forgetting to write this as v, the input here of v as u. We're making it root x. It has to be u. It has to be, because u is this. And so we're saying this function v and this function g, this is actually equivalent. It is the exact same as this function here, because v stands for the square root of u, and u stands for 3x squared plus 4. So it's an identical thing. We have to make sure we carry those variables through. We can't use x's for these other functions. G prime, well, I need to take the derivative of f, but oh wait, I don't know f. G prime is just f prime of v, because I do have an expression for f prime. So then g prime of x is 6x times 1/2 u to the negative 1/2 times f prime of v. And now we need to clean that up. I can't leave u's and v's in there. Also, I can make the 6 times the 1/2 a 3. So this is going to be 3, and then times 3x squared plus 4, because that's u to the negative 1/2, and then times f prime of v. Well, they gave me f prime. It's this wonderful function, and then I have to plug v into that. So that's going to be ugly, but we can do it. So times, oops, no more laser pointer, times, let's go ahead and slide this guy over a little bit, I guess. sine stylus drama, sine of pi of v plus, what is it? I should have done a better job of remembering. V squared plus 3. Ugh, yuck. V squared plus 3. And now I can't leave that as v, so the substituting fun continues. 3 times 3x squared plus 4 to the negative 1/2 times sine of pi. Well, v is really the square root of u, and u is really 3x squared plus 4. So it's pi times 3x squared plus 4 underneath the square root there. Plus, well, v is the square root of 3x squared plus 4, and then I'm squaring it, so it's just then 3x squared plus 4, and then plus that extra 3. Whew! Chain rule fun. And then the question was to find g prime of 2. That whole beauty is g prime of x, so I just replace every single x. Here's one, here's one, here's one, with a 2. Excellent. Pause, write it down, think back through it. If you have any questions on where I got any of it, send me a message if you can't figure it out. Moving on. And then part D, let h be the inverse of f. Find h prime of 2. So what they've said is that h is equal to f inverse of x. So when they say find h prime of 2, that's the same as saying find f inverse prime of 2, or in other words, the derivative of f inverse at 2. So that means that 2 in our notation from class is our b value. We need to know the a value, because in order to find f inverse, the derivative of f inverse of 2, I need to do the reciprocal of f inverse of whatever a value corresponds with 2. Or again, on the idea is that on the inverse, it's b comma a, and on the original, it's a comma b. So, what's the a value that goes with 2? What on the original, b is 2, that's the output. What's the input from the original that outputs 2? Well, what do I know about f? I know its derivative, and I know that if you input 0, you output 2. If you input a, you output b. A is 0. So what I need to figure out the derivative of the inverse of f at 2, I need 1 over the derivative of the original at 0. And because I have the function for the derivative of the original, this is the same. This is the same as saying 1 over f prime of 0. It's just different ways to write the derivative. And so you have the equation for f prime. You can plug 0 into it. And I believe you get 3. So I believe your answer is 1/3. But I'll leave you to double check that. So that's definitely a gnarly one. No doubt about that. Those first two are intimidating to start with. So again, if you had trouble, don't be too worried about that. These are ugly ones to go through. But that doesn't mean just forget it and say, oh, Mr. Shields said it's an ugly one, I don't need to worry about it. And that's not what I said. I said Don't worry if you had trouble, but make sure that you now understand it. Okay. Might as well just keep going here, I think, right? We can do a few more without making this an absurdly long video. At least one more. Okay. Number 3. G satisfies this. Which of the following statements about the inverse of G must be true? Even before I look at this, just knowing what we worked on today and what we just did in that last problem, I'm immediately thinking, okay, I have some original function here, G, and they're asking me about its inverse. So originally, I have A equals 4 and B equals 6, because this is the original, and they're going to ask me about the inverse of G. And so I also know that G prime of 4 is negative 2. So what I know is that the relationship is the derivative of the inverse of G at B, which is 6, has to be the reciprocal of the derivative of the original G at A, meaning that the derivative of the, sorry, I don't like how I wrote that, meaning that the derivative of the inverse at 6 is 1 over G prime of 4, because 4 is A. And that is 1 over negative 2. So G inverse prime, which is another way to write this, G inverse prime of 6 is negative 1/2. That's what I know. Which of these matches that? The last one. G inverse prime of 6 is negative 1/2. That's my answer. Number 4 is an admittedly ugly one. I will be honest, I did not read it as carefully as I should have when I assigned it. I thought it was going to be something super similar to number 3 here, which is a more straightforward one. Not necessarily easy, but more straightforward. And so what's happening in G is we really have to, or sorry, in 4, is we really have to focus on the fact that f and g are inverse functions that are differentiable for all x. Now, in order to be inverse functions, that means that f is the inverse of g and g is the inverse of f, and they're both functions, meaning they both pass the vertical line test. That's only possible if the original function passes the horizontal line test. So what that means, in order to pass the horizontal line test, the function, the graph, has to be either always decreasing or always increasing. It can't change, because if it ever changes to decrease, changes direction, now it fails the horizontal line test, and its inverse would fail the vertical line test. So that's not allowed. And so what ends up happening here, and again, this particular question, don't worry too much about this one. This, for right now, this is a gnarlier one than I anticipated. So what we know, we're given here that g prime of negative 2 is negative 4, which means that g is always decreasing, because we just established it can never change from increasing to decreasing or decreasing to increasing. It's always got to be either decreasing or increasing. Since the derivative is negative, at one point, it has to be negative at all points. And then, because the derivative of the inverse is simply the reciprocal of the derivative of the original, there's no opportunity for the inverse to change sign either, which means that f prime has to always be negative. So the one that has to be false is 1. Because that shows that the derivative of f, which is the inverse of g, is positive, and that's not possible. The other ones that are negative, they don't have to be false. We don't know what f prime of 3 is. They don't tell us. And if they had told me something about f prime of -4, which is what I assumed they were going to ask you about and didn't read it carefully enough, then that's something I would know about. But they didn't, so it's 1 here because of that inverse has to always be increasing or decreasing there. Not one that I'm super worried about for right now, and my fault for assigning that one for you. Last one, we can do it here. For which of the following functions f does f inverse prime of 20 equal 1/5? So if I break this down and think about it in terms of our definition, we're saying f inverse prime of b is equal to 1 over f prime of a, which means that f prime of a has to equal 5. Yeah? It's also saying that since b is 20, that's my input on the inverse. It has to be the output on the original, right? Because on the original I have the point a comma b. Original a comma b, something comma 20. So there's got to be a place, a value of a, where the original function will output 20 and the derivative of that original function will output 5. So what I would think about first is, okay, if the output of the function is supposed to be 20, I should be able to set the equation equal to 20 and then solve for a and then double check whether or not this is true. So that's what I'm going to do. So I'm going to take my first one and I'm going to say, okay, 20 equals x plus 5, x equals 15. Is the derivative of that, f prime of 15, is that equal to 5? Because this is my a value, and we know that f prime of a has to be 5. Well, for the first one, no. F prime is 1 always, right? So no, that's not it. Moving on to part B. If I set that equal to 20, 20 is equal to x cubed plus 5x plus 20. Well, that means that x is equal to 0, and that's my a value. So is f prime of 0 equal to 5? Well, f prime of x in this case is 3x squared plus 5, and f prime of 0 is 5. So it's B. All right. 2 longish videos there to go over that. I know that some of these were pretty tricky, pushing our thinking a little bit more. It's not just straightforward. But these are the types of questions we can expect on the AP exam. So we're going to try to sprinkle some of these ones in throughout the year. All right.